I hope you're all having a great day. I'm Mr. Rich. Thank you for joining me. We're looking here at cone volumes. We will be doing two questions. We have right here a right circular cone which has a height 10 units and a radius 5 units. As you see right here, 10 and 5. If it is sliced 4 units from its peak, find the original and the new volume. What is a right circular cone? Well, if you were to draw a three-dimensional cone, within it you could demonstrate a right triangle. There's a circular base, but you have a right triangle which forms right over here. Hence it's called a right circular cone. In this instance, we have a right circular cone which has a height which is 10 units. It has this radius over here, that's 5 units. But then we're saying it is sliced. You slice it here 4 units from the top. 4 units from the top, and you pluck out this new cone, and you know it's going to be shorter because the rest has been left away. We're only looking at the top part which remains from the peak 4 units down. What is the volume over here? What's the volume over here? And let's figure it out. Volume for a cone is always pi r squared h over 3. 1 over 3 pi r squared h. If you are aware of that, we can find the original volume. It's not hard. We have the original height. It's 1 over 3 pi, the original height, which is 10, and then the original radius, which is 5, but it's 5 squared because it's 1 over 3 pi r squared h. You just have to compute that, and that's not going to be too hard. It'll be 25 times 10, and you'll have 250. We'll keep everything here in a fraction. 250 pi over 3, that's the original volume, and we can just write VO, original volume. We have to do the new volume. The only problem is when you are slicing it, we know the height, but we don't know what the radius is because you've sliced it and you've generated a smaller right circular cone. We have a height here is equal to 4, but what is this new radius? Well, the new radius is not hard to determine because everything is stemming from the same circular cone. You can do ratio and proportion to determine it. If you have an original height which is 10 and it was associated with a radius of 5, now you have a new cone developing from the same original cone which has a height 4, and what must its radius be? You can solve for that. You'll have 10r is equal to 20 and r is equal to 2, and that right there will give you your new radius for that new cone. So we have a new height, we have a new radius, and we just plug it in. Volume new volume is equal to 1 over 3 pi times height, which we know to be 4, and times the radius square, which we know 2 square. 4 times 4, which is 16 pi over 3 is your new volume. So you end up seeing a substantial decrease in the volume as a result of this slice. But we have the original here, 250 pi over 3, and the new is 16 pi over 3, and the question is done. So it's not too hard. You can always remember this formula right over here. And the fact that you can do something like this, ratio and proportion, to determine a missing dimension. Our second and last question is this. We have a cone, a right circular cone, which has its volume increased by 25%. If HO is equal to HN, the original height is equal to the new height. Express the new radius in terms of the old radius. It seems like a seemingly tricky question, but think about it logically. Express the new radius in terms of the old radius. We can use some symbols. Rn equals my new radius, Ro equals my original radius. We can use VO for my original volume and Vn for my new volume. We have a cone which has its volume increased by 25%. If supposedly you were to take the original volume and you were multiplying it and increasing it by 25%, you're really looking at VO times 1.25, because 1.25 represents 25% of the original, and you know that to be the case. In this instance, VO 1.25, or you can say 1.25 VO will be equal to your new volume, and you can express it that way. 1.25 VO, 1.25 times the original volume will equal to your new volume. Always think about it as this. You have an original which is 1 and you're increasing it by 25%, so you'll have 1.25. But all the components of the original volume will equal to the new volume with this factor of 1.25. 1.25 times pi r squared h over 3, which is my original volume, is equal to pi r squared h over 3 for the new volume. If you know that the original height is equal to the new height, you can literally cancel them out, because they're going to cancel out anyways. What can cancel out are the 3's because they're same on both sides. The pi can cancel out on both sides because they're the same. The only thing you're left with is 1.25 or the original. Remember, we're looking here at this side. The original radius square is equal to your r and the new radius squared. When you now solve for this, because we have to express the new radius in terms of the old radius, you'll solve for rn. Rn is equal to 1.25 ro square root. You can simplify this. You'll have the new radius is equal to r, which is the original radius. It can come out because perfect square here and the root of it 1.25, and that right there would demonstrate the relationship between the new radius and the old radius, given that the heights of both cones are the same, but one has a volume larger than the other, and this volume increase is only resulting because you have two cones which have the same height, but one is more broad because it's larger cone in terms of its width. It's larger radius and a smaller radius, hence this is 1.25 times larger. I know I haven't drawn it very well, but you can understand you can have the same height, but by merely increasing the radius dimension, the width of that cone, you can increase the volume, and that's exactly what we're looking at. So to answer your question, we have the answer right here. The new radius is expressed in terms of the old radius. The new radius is equal to old radius times root of 1.25, and the question has been completed, and that's about all we'll be looking at in this particular video. Have a good day. Bye.